the pressure inside the soap bubble is very much greater than the atmospheric pressure. Grating andre, it is an arrangement on which we get spectral lines. Hello students, this is Samson Deepak, Faculty of Physics, Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. In my today's class, the CET paper of discussion will refer to the year 2004. As we have seen in all previous sessions, again here it is a blend of concepts, assertions and calculations. A quite interesting paper we solve starting it now. The first question. The question says, a thin plano-convex lens, thin plano-convex lens acts like a concave mirror. Plano-convex lens is acting like a concave mirror of focal length 0.2 meter when silvered from its plane surface. When the plane surface is silvered, the plano-convex lens is behaving as a concave mirror. Now he says, the refractive index of the material of the lens is 1.5. I have been asked to calculate the radius of curvature of the convex surface of the lens. Dear students, whenever you have questions from optics to solve, they're quite interesting and slightly applicable. ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? ಒಂದು ಪ್ಲೇನೋ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಇದೆ. ಸೊ ಮಕ್ಕಳೇ, ಪ್ಲೇನೋ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಯಾವ ರೀತಿ ಪಿಕ್ಚರೈಸ್ ಮಾಡೋಣ? ಒಂದು ಕಡೆ ಕಾನ್ವೆಕ್ಸ್ ಸರ್ಫೇಸ್ ಇದೆ, ಇನ್ನೊಂದು ಕಡೆ ಪ್ಲೇನ್ ಸರ್ಫೇಸ್, ಪ್ಲೇನೋ ಕಾನ್ವೆಕ್ಸ್. ಈಗೇನಾಗುತ್ತೆ? ಈ ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ ನ ಸಿಲ್ವರ್ ಮಾಡಿದ್ರೆ, ಇಫ್ ವಿ ಆರ್ ಮೇಕಿಂಗ್ ದ ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ ಸಿಲ್ವರ್ಡ್, now this convex lens is behaving as a concave mirror. When you are silvering the plane surface, the lens behaves as a concave mirror whose focal length is 0.2. Always remember this expression. For a plano-convex lens and a mirror, 1 by focal length of the mirror is always 2 by focal length of the lens. ನೀವು ಈ ರಿಲೇಷನ್ಗಳನ್ನ, ಈ ಕಾನ್ಸೆಪ್ಟ್ಗಳನ್ನ ಮನಗೊಳಿಸ್ಕೋಬೇಕಾಗುತ್ತೆ. 1 by focal length of the mirror is 2 divided by focal length of the lens. Very clearly in the problem he says concave mirror of focal length 0.2 meter. So focal length of the mirror is 0.2 meters. So what will be the focal length of the lens there? So this is 2 into 0.2, which is 0.4 meter. So very clearly, now I have got the focal length of the lens, which is 0.4 meter. ಇನ್ನೇನ್ ಡೇಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ? Refractive index of the material is given, which is 1.5. ಏನನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಆಫ್ ದಿ ಕಾನ್ವೆಕ್ಸ್ ಸರ್ಫೇಸ್. ನೋಡಿ, ಫೋಕಲ್ ಲೆಂತ್ ಆಫ್ ದಿ ಲೆನ್ಸ್ ಗೊತ್ತು, ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದಿ ಲೆನ್ಸ್ ಗೊತ್ತು, ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಕಂಡುಹಿಡಿಬೇಕು. ಯಾರು ನಮ್ ಸಹಾಯಕ್ಕೆ ಬರ್ತಾರೆ? ಮಿಸ್ಟರ್ ಲೆನ್ಸ್. Lens maker's formula. So we have 1 by f equals n minus 1 by r1 plus 1 by r2. ಮಸೂರ ನಿರ್ಮಾಣಿಕನ ಸೂತ್ರ ಅಂತ ಕನ್ನಡದಲ್ಲಿ ಸುಂದರವಾಗಿ ಹೇಳ್ತೀವಿ. ಲೆನ್ಸ್ ಮೇಕರ್ಸ್ ಫಾರ್ಮ್ಯುಲಾ. My dear students, here R2 becomes infinity. For what reason? It is a plano-convex lens. One surface is plane, so R2 becomes infinity. So I have 1 by 0.4 is n is 1.5 minus 1.5 by into 1 by R1, or R1 is 0.5 into 0.4. So 0.2 meter will be the answer. So on simple simplification, using lens maker's formula, knowing these concepts, see very clearly I have arrived at the answer. So plano convex lens iddag ನೆನಪಿಟ್ಕೊಳ್ಳಿ, R2 infinity ಆಗಬೇಕು, ಯಾಕಂದ್ರೆ ಒಂದು ಸರ್ಫೇಸ್ ಪ್ಲೇನ್ ಇದೆ. And this is how you connect focal length of a mirror and focal length of a lens. Next one. The physical quantity which has the same dimensions as Planck's constant. Almost every session I have worked out. Every paper I have worked out. You have seen there is a question on dimensional analysis. ಕೆಲವೊಂದು ಸರಿ ಆ ಟಾಪಿಕ್ ನ ತುಂಬಾ ಲೈಟ್ ಆಗಿ ತಗೊಂಡಿರ್ತೀವಿ. ನೋ, That is the fundamental to understand any higher physics. So now the question is, the physical quantity having the same dimensions as Planck's constant. ನಾಲ್ಕು ಕ್ವಾಂಟಿಟಿಗಳು ಕೊಟ್ಟಿದ್ದಾರೆ. ಬೋಲ್ಟ್ಜ್ಮನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಫೋರ್ಸ್, ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಅಂಡ್ ಆಂಗ್ಯುಲಾರ್ ಮೊಮೆಂಟಮ್. ಈ ನಾಲ್ಕು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿಗಳಲ್ಲಿ ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುವ ಡೈಮೆನ್ಷನ್ಸ್ ಬೇರೆ ಯಾವುದಕ್ಕಿದೆ? ಫಸ್ಟ್ we will write the dimensions for Planck's constant. From where will I get? Simplest expression to get Planck's constant is energy of a photon. We know energy of a photon is E equals h nu. h ನೇನ್ ಕರಿದ್ವಿ? Planck's constant. Nu frequency. So idrinda h becomes equal to E divided by nu. What is the dimensions of energy? Tip of the tongue you should have. M L square T minus 2. Dimensions of frequency. Frequency is 1 divided by time. So T minus 1. So this has the dimensions M L square. Minus 1 ಮೇಲ್ ಹೋದ್ರೆ plus 1. Minus 2 plus 1 is minus 1. Andre, which among the four options now has to have the dimensions M L square T minus 1? Very clearly I know it cannot be force, because force is mass into acceleration. M L T minus 2. I know it cannot be Boltzmann constant. Linear momentum is very easy to define. Mass into velocity. So M L T minus 1. My crude analysis says it has to be angular momentum, and let us check for that angular momentum. Now, how do I define angular momentum? So, angular momentum is M V R. Bohr's postulates allu ottira, system of particles allu ottira. Angular momentum is M V R, which means mass, velocity is LT minus 1, radius is L, or this is M L square T minus 1. So very clearly you see angular momentum is having the same dimensions as Planck's constant. So the answer is angular momentum. Very simple. My superficial analysis, I eliminated the three options. I verified whether angular momentum is correct, and then it is yes, it has the same dimensions as Planck's constant. The next one, the problem says a balloon is raising vertically up with a velocity 29 meter per second. So there is a balloon here which is raising vertically up with a velocity 29 meter per second. Since the balloon is raising vertically upwards, vertically ಮೇಲ್ ಹೋಗ್ತಿರೋದ್ರಿಂದ, I take the velocity as minus 29 meter per second, because it is defining upward motion. It is rising vertically upwards. A stone is dropped from it. Very beautiful. A stone is dropped from it and reaches the ground in 10 seconds. So here is a stone which is dropped from it and it reaches the ground in a time interval of 10 seconds. ನೀವಿಲ್ಲಿ ಏನು ಅನಲೈಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಇಷ್ಟೇ. The balloon is exhibiting vertically upward motion and the stone which is dropped from it is under free fall. It is dropped, coming down under the influence of gravity. The height of the balloon when the stone was dropped from it, ಅವ್ರು ಏನ್ ಕೇಳ್ತಿದ್ದಾರೆ? Not the height of the balloon when the stone is reaching the ground. Allah, height of the balloon when the stone started dropping from the balloon. ಈ ಬಲೂನ್ ಇಂದ ಸ್ಟೋನ್ ಕೆಳಗಡೆ ಡ್ರಾಪ್ ಆಗ್ಲಿಕ್ಕೆ ಶುರುವಾದಾಗ what was the height of the balloon? So now I use the expression h is minus ut plus half gt square. So this is minus 29 into 10 plus half, g is 9.8 into t square is 100. So this is minus 290 plus, so this goes 4.9 times 490, or this is 200 meters. So the answer is the second option, which is 200 meters. The next one. A beautiful question again. A thread is tied slightly loose to a wire frame. ನಮ್ಮ ದಸರಾ ಟೈಮಲ್ಲಿ ಮೈಸೂರು ಎಕ್ಸಿಬಿಷನ್ ಅಲ್ಲಿ ಈ ತರದ್ದು ಆಟಿಕೆಗಳು ನಿಮಗೆ ಕಾಮನ್ ಆಗಿ ಸಿಕ್ಕುತ್ತೆ. ಒಂದು ವೈರ್ ಫ್ರೇಮ್ ತಗೊಂಡಿರ್ತಾರೆ, ಟು ವಿಚ್ ದೇ ಹ್ಯಾವ್ ಟೈಡ್ ಅ ಥ್ರೆಡ್ as shown in the figure. So you can see here, this is the wire frame to which we have tied a thread. And the frame is dipped in soap solution and taken out. ನೀವು ಎಕ್ಸಿಬಿಷನ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ಆ ಸೋಪ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಅಲ್ಲಿ ಡಿಪ್ ಮಾಡಿಕೊಂಡು ಬಬಲ್ ಊದ್ತಾ ಇರ್ತಾರೆ. ಎಕ್ಸಾಕ್ಟ್ಲಿ ದ ಸೇಮ್. The frame is completely covered with the film. Film andre air bubble anta artha. When the frame is dipped inside the bubble, it is completely covered with the film. Now, the portion A is punctured with a pen or a pin. This portion A is punctured with a pin. What happens to the thread? Very simple. ಒಂದು ವೈರ್ ಫ್ರೇಮ್ ಇದೆ, ಸಣ್ಣಗೊಂದು ಥ್ರೆಡ್ ಅನ್ನು ಕಟ್ಟಿದ್ದೀನಿ. A small thread is tied to the wire frame. I am dipping that wire frame into a soap solution. Take a pin, puncture the frame region A. What happens to the thread ಅಂತ ಕೇಳಿದ್ದಾರೆ. ನಾವಿಲ್ಲಿ ಏನ್ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ, the pressure inside a soap bubble is 4T by R, which is very much greater than the atmospheric pressure. Please do keep this in mind. The pressure inside the soap bubble is very much greater than the atmospheric pressure. Andre, when I puncture this region A, pin takondo a region A na puncture madidre, air flows out of that region. ಆ region ಇಂದ ಗಾಳಿ ಹೊರಗಡೆ ಬರುತ್ತೆ, which means now the thread will be convex with respect to A, ಯಾಕಂದ್ರೆ ಗಾಳಿ ಹೊರಗಡೆ ಹೋಗಿದೆ, and concave with respect to B. ಬ್ಯೂಟಿಫುಲ್ ಆಗಿದೆ ನೋಡಿ. Why? The simple reason, pressure inside the air bubble, soap bubble, is greater than atmospheric pressure. So naturally, when you puncture A, air has to flow out through A. So the thread is convex with respect to it. B, the thread is concave with respect to it. So here the answer is either it becomes concave towards A or convex towards A, depending on the size of A with respect to B. This is already done in my previous session itself. Watch that session. Before that, take a pen, pencil, try to work out. It is an assignment. D will be the answer. Sixth one. When light is incident on a diffraction grating. Grating andre, it is an arrangement on which we get spectral lines. Previous syllabus alotidvi. Now you are not exposed to that, but now just understand grating is an arrangement on which we obtain spectral lines. When light is incident on a diffraction grating, the zero order principle n equals 0 ಆಗಿದ್ದಾಗ you don't get any other colors except for white because it is zero order principal maxima. Zero order ಅಲ್ಲಿದ್ದಾಗ ಯಾವುದೇ ಬೇರೆ ಕಲರ್ಗಳು ಸಿಕ್ಕಲ್ಲ. It is except white. So the answer is the fourth option, which is white. H Polaroid is prepared by stretching polyvinyl alcohol and then impregnating with iodine. Polyvinyl alcohol and stretch ಮಾಡಿ iodine ಅದ್ರ ಮೇಲೆ ಸಿಂಪಡಿಸ್ತಾರೆ. That is where you get H Polaroid. Again, in the previous syllabus, we used to study H Polaroids and K Polaroids. This is the method used to prepare H Polaroid. SI unit of permittivity. Permittivity ಅಂತ ಹೇಳ್ತಿದ್ದಂಗೆನೆ ಯಾರ ಅಸಿಸ್ಟೆನ್ಸ್ ಬರ್ತಾರೆ? Mr. Coulomb. So what is the mathematical form of Coulomb's law? F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. I need the SI unit of permittivity. Which term is called permittivity here? Epsilon naught. So when I rearrange, epsilon naught goes to the numerator, 1 by 4 pi F. F comes to the denominator, Q1 Q2 by R square. 1 by F, SI unit of force ಏನು? Newton, but it is 1 by F. So Newton minus 1, Q into Q, charge. SI unit Coulomb, Coulomb square. Distance is meter, meter square. Numerator hodaga meter minus 2. So this is the SI unit of permittivity. The next one, pretty interesting. A spherical drop of capacitance 1 microfarad. Spherical drop of capacitance 1 microfarad is broken into 8 equal or 8 drops of equal radius. Spherical drop is broken into 8 smaller drops of equal radius. Then the capacitance of each smaller drop has to be calculated. Andre, there is a spherical drop. So this is a bigger spherical drop of capacitance 1 microfarad. ಇದನ್ನ ಏನ್ ಮಾಡ್ತಿದ್ದಾರೆ? They are breaking this into 8 smaller drops of equal radius. So these are the smaller drops of equal radius. ಅವ್ರು ನಮಗೆ ಈ ಪ್ರತಿಯೊಂದು ಸ್ಮಾಲರ್ ಡ್ರಾಪ್ ಇದೆಯಲ್ವಾ ಅದ್ರದ್ದು ಕೆಪಾಸಿಟೆನ್ಸ್ ಕೇಳಿದ್ದಾರೆ. Now how do we go about with this? ಒಂದು spherical bigger drop ಇದೆ, ಅದನ್ನ 8 ಸ್ಮಾಲರ್ ಡ್ರಾಪ್ಸ್ ಆಗಿ ಬ್ರೇಕ್ ಮಾಡಿದೀವಿ. And all those 8 smaller drops have equal radius. Therefore, volume of the bigger drop should be equal to the volume of those 8 smaller drops. Alva? Now, what is the volume of the bigger drop? Spherical ಆಗಿರೋದ್ರಿಂದ 4/3 pi r cube ಅಂತ ಬರ್ದೆ. Where r, capital R, is the radius of the bigger drop. So this is equal to volume of the smaller drops. ಎಷ್ಟು smaller drop ಇದೆ? 8. So 8 into 4/3 pi r cube. So small r, radius of each smaller drop. Volume of the bigger drop, volume of the smaller drop. 4/3 pi, 4/3 pi cancel ಆಯ್ತು. ಕ್ಯೂಬ್ ರೂಟ್ ತೆಗೆದಾಗ capital R is 2 small r. So this is the radius of the bigger drop. What is that I have to calculate? Capacitance of the smaller drop. So capacitance of the smaller drop, I say, is 4 pi epsilon naught into r. ನಿಮ್ಗೆ ಇದೆಲ್ಲ ಗೊತ್ತಿರಬೇಕು, ಕೆಪಾಸಿಟರ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಓದಿದ್ದೀರಾ. ಕೆಪಾಸಿಟೆನ್ಸ್ of a spherical conductor expression ಬರ್ದಿದ್ದೀರಾ. 4 pi epsilon naught into r. Now, what is capacitance of the bigger drop? I say 4 pi epsilon naught into capital R. Capital R, radius of the bigger drop, which means capacitance of the bigger drop is 4 pi epsilon naught. What is capital R equals to? 2 times small r. So this is capacitance of the bigger drop is 4 pi 2. So therefore, if I take CS by CB, it is 1/2 microfarad. So the answer is 1/2 microfarad. See, very simple. There is nothing here. Some ideologists try to remember with the concept, you are getting the answer. Next one. Two equal forces. Very important term. Two equal forces. Each force he is calling as P. ಎರಡು ಈಕ್ವಲ್ ಫೋರ್ಸ್ಗಳಿದೆ. ಪ್ರತಿಯೊಂದು ಫೋರ್ಸ್ ನ P ಅಂತ ಕರೀತಿದ್ದಾರೆ. Act at a point inclined to each other at an angle of 120 degrees. magnitude of their resultant. Simple expression alva idu. Nam first PUC ಓದ್ತೀವಲ್ಲ, when two forces act at a common point, the magnitude of their resultant is root of p square plus q square plus 2pq cos theta. ಮಕ್ಕಳೇ, ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಭಾರಿ ಪ್ರಾಮುಖ್ಯವಾದದ್ದು. The magnitude of the resultant of two forces is always given by this expression. ಅವ್ರೇನ್ ಹೇಳ್ತಾರೆ, two equal forces, P is equal to Q. So R becomes P square plus Q is also P square plus 2p square, P into P, cos 120, which is minus half. They are inclined at an angle of 120 degrees. Cos 120 is minus half. So this is root of 2p square minus p square, which is root of p square. So the answer is P. They are inclined at an angle of 120 degrees. Cos 120 is minus half. So the answer turns out to be P. The next problem. Again, an interesting one. If two waves of same frequency and amplitude respectively on superposition produce a resultant disturbance of the same amplitude, the wave differ by a phase. ಅವ್ರು ಏನ್ ಹೇಳ್ತಿದ್ದಾರಂದ್ರೆ, see, that terminology in the question is made absurd to test y'all. Two waves of the same frequency and amplitude. ಇದು ಒಂದು ವೇವ್ ಇದೆ, ಇದ್ರ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಎ ಅಂತ ಕರಿತೀನಿ. Another wave with the same amplitude A. They superpose. Superpose ಅಂದ್ರೆ ಏನ್ ಮಕ್ಕಳೇ? Cross each other. When they superpose, they give a resultant wave which will have the same amplitude as these two waves. ಇದೆರಡು ಸೂಪರ್ಪೋಸ್ ಆದವು, ಒಂದು ರಿಸಲ್ಟೆಂಟ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಸಿಕ್ತು. It will have the same amplitude, which means now the amplitude of the resultant wave is A plus A cos phi by 2. ಎಲ್ಲಿಂದ ಬರೆದ್ರು ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್? ಅದನ್ನೇ ನಾನು ಹೇಳಿದ್ದು. ಸ್ಟೇಷನರಿ ವೇವ್ಸ್ ಅಂತ ಓದಿದ್ದೀರಾ. ಫಾರ್ಮೇಶನ್ ಆಫ್ ಅ ಸ್ಟೇಷನರಿ ವೇವ್ ಆರ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ವೇವ್ ಯು ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್. ದೇರ್ ಯು ರೈಟ್ ಅನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಸ್ಟೇಷನರಿ ವೇವ್. In terms of amplitude, I have taken the expression. So here, this A equals 2A cos phi by 2 or cos phi by 2 is equal to half. A mat A cancel ಆಯ್ತಿಲ್ಲಿ. cos phi by 2 ಎಷ್ಟು ಸಿಕ್ಕುತ್ತೆ? ಹಾಫ್ ಸಿಕ್ಕುತ್ತೆ. ಈ ವ್ಯಾಲ್ಯೂನ ಗಮನಿಸಿ. ಎಲ್ಲಾದ್ರೂ cos phi by 2 in terms of pi baribahuda? Cos phi by 2 is half, which means this can also be written as cos pi by 2 is cos pi by 3. This trigonometry you should know. Cos phi by 2, which is half, is cos pi by 3. Cos cancel aito, so phi is 2 pi by 3. So the answer is 2 pi by 3. Again an interesting question. Simple. Nim assertion mel hoguttaste. A man standing between two cliffs. Cliffs andre ಎರಡು ಬೌಲ್ಡರ್ಗಳು, ಎರಡು ಸ್ಟೋನ್ಸ್ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ. Claps his hands and starts hearing a series of echoes at intervals of 1 second. I expect that the person would have visited Gol Gumbaz. He's standing between two cliffs. He's overwhelmed. Gol Gumbaz nodi tumba enjoy ಮಾಡ್ತಿರ್ಬೇಕು. He started clapping its hands, and the speciality of Gol Gumbaz echoes. He starts hearing a series of echoes at intervals of 1 second. ಪ್ರತಿ 1 ಸೆಕೆಂಡ್ಗೂ series of echoes ಕೇಳಿಸುತ್ತೆ. If the speed of sound in air is 340 meter per second, then what is the distance between the cliffs? ನೋಡಿ ಇಲ್ಲಿ, this is one cliff, this is the other cliff. I say D is the distance between the two cliffs, stones ಅಂತ ಹೇಳಿದೆ. And the man is exactly in between, ಅಲ್ಲಿ ಹೇಳಿದ್ದಾರೆ between two cliffs ಅಂತ. So what is the distance between the man and one of the cliffs? D by 2 ಆಗುತ್ತಲ್ವಾ ಮಕ್ಕಳೇ? Distance between two cliffs is D. Man is standing exactly in between. So distance between him and the cliff, one of the cliff, is D by 2. He starts, yes, clapping. He is generating sound waves, and the echo reaches him in a time interval of 1 second. Prati 1 second go series of echo is heard. Distance between the cliffs has to be calculated if the speed of sound is 340. ಸಿಂಪಲ್ ಆಗಿದೆ, ಏನ್ ರಾಕೆಟ್ ಸೈನ್ಸ್ ಇಲ್ಲ. ಸ್ಪೀಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಟೈಮ್ ಗೊತ್ತು. ಡಿಸ್ಟೆನ್ಸ್ ಯಾವ ರೀತಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ? D is velocity into time. Speed is distance divided by time. So distance is velocity into time. Now what is this distance equal to? 2 into D by 2. If this is D by 2, this is also D by 2. So 2 into D by 2 is the actual distance between the cliffs. So this is 340 into 1. So D is nothing but 340 meters. 13th, I've already solved this in my previous session. 2.4 millimeter is the answer. Exactly same. The same data, work out, you arrive at the answer. This, as I told, I will take it as a repository discussion. This is with respect to polarization, where we studied specific rotations, levorotatory rotations, dextrorotatory rotations, specific rotations, which depends upon the concentration of the solution, angle of rotation, length of the tube. Since this is not adopted for your syllabus, I will not take up this discussion now. Now, an electron is accelerated through a potential difference 45.5 volt. The velocity acquired by it. See, when we accelerate an electron by applying some voltage, then its kinetic energy is expressed in terms of electron volt. Alva? ನೀವು ಓದಿರ್ತೀರಾ ಇದನ್ನ? Whenever electron accelerates by applying certain potential difference, its kinetic energy is expressed in electron volts, which means half mv square is E into V. Idu velocity aito, this is volts potential. Or here V square is 2eV by m. So V is root 2 charge of the electron 1.6 into 10 power minus 19, 45.5 mass of the electron 9 into 10 power minus 31. Now, ಯಾವ ರೀತಿ orally ಇದನ್ನ simplify ಮಾಡಬಹುದು? 1.6 into 2 is 3.2, 3 ಅನ್ಕೊಳ್ತೀನಿ. 46 into 3, somewhere 138. 138 divided by 9. Take the square root. You get the answer as 4 into 10 power 6 meter per second. Next one, students. When a body is connected to Earth, electrons flow from the Earth, flow into the body. This means the body is already positively charged. Now, effective capacitance between A and B. A system of capacitors where I have to calculate the effective capacitance between A and B. One Wheatstone's network idagide. So this capacitor in the middle will not contribute to the capacitance. Umpteen number of times I have told the capacitance in the middle of the network will not contribute to the capacitance. 3 and 6 are connected in series. So CS1 enaito 3 into 6 divided by 3 plus 6 18/9 2 ಆಯ್ತು. Similarly 4 and 8 are in series, so CS2 is 4 into 8 divided by 4 plus 8, 32/12, so 8/3 ಆಯ್ತು. CS1 and CS2 are in parallel, so CP is CS1 plus CS2, 2 plus 8/3, so the answer has to be 14/3 microfarads. So if you check, it turns out to be 14/3 microfarad. Now, which state of triply ionized beryllium, which state of triply ionized beryllium has the same orbital radius, as ground state of hydrogen? He says triply ionized beryllium has the same orbital radius as the ground state of hydrogen. Which state of beryllium will have this? How is radius related to orbit number, atomic number? Recalling the expression for radius, n square h square epsilon naught pi m ZE square. Atoms chapter allo odirtira, where we have derived an expression for radius. Keeping all other things constants, so R is proportional to n square divided by Z. Alva, H constant, epsilon naught constant, pi constant, m constant, e constant. So R proportional to n square divided by Z, which means R1 by R2 equals n1 square by n2 square into Z is inversely proportional Z2 by Z1. Very clearly he says R1 is equal to R2, same orbital radius anta clear kottidare. So n2 square is n1 square into Z2 by Z1. N1 ground state of hydrogen. Which is the ground state of hydrogen? 1. Atomic number of beryllium 4. Atomic number of hydrogen 1, which implies N2 is nothing but 2. So the answer is equal to 2. If m is the atomic mass and A is the mass number, packing fraction is given directly by the expression m minus A divided by A. 20th, radioactivity ಮೇಲಿದೆ. Again interesting. A count rate meter shows, count rate meter ಅಂದ್ರೆ ಈಗ ನೀವು ಕ್ರಿಕೆಟ್ ನೋಡ್ಲಿಕ್ಕೆ ಚಿನ್ನಸ್ವಾಮಿ ಸ್ಟೇಡಿಯಂಗೆ ಎಂಟರ್ ಆಗ್ತೀರಾ, ಅಲ್ಲೊಂದು ದೊಡ್ಡ ಫ್ಲಾಶ್ ಬೋರ್ಡ್ ಇರುತ್ತೆ. ಈ ಟೈಮಲ್ಲಿ ಇಷ್ಟು ಜನ ಎಂಟರ್ ಆದ್ರು, ಈ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಇಷ್ಟು ಜನ ಎಕ್ಸಿಟ್ ಆದ್ರು. ಆ ರೇಟ್ ಮೆಜರ್ ಮಾಡ್ತೀವಲ್ಲ, ಅದನ್ನ ಕೌಂಟ್ ರೇಟ್ ಮೀಟರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಹಿ ಸೇಸ್ a count rate meter shows a count of 240 per minute from a given radioactive source. Initial count ಎಷ್ಟು? Count ಅಂದ್ರೆ atoms ಅಂತಿಲ್ಲ ಅರ್ಥ. So initial number of atoms is 240 per minute. 1 hour later, the meter shows a count rate of 30 per minute. 1 hour later, after certain interval of time, the number of atoms remaining is 30. Then the half-life of the source. Last al bardvalva expression, n is equal to n naught half time for disintegration divided by half-life. ನೋಡಿ, ಒಂದು ಸೆಷನ್ ಅಲ್ಲಿ ನಾವು ಉಪಯೋಗಿಸಿರುವಂತ ರಿಲೇಷನ್ ಎಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ಸಾಲ್ವ್ ಮಾಡಕ್ ಹೆಲ್ಪ್ ಮಾಡ್ತಿದೆ. n number of atoms remaining 30, initial number of atoms 240, half time interval per minute 60, t half. Now 30 divided by 240, 1 by 8, which I write as half to the power cube. 30 divided by 240, 3 by 24, 1 by 8 ಸಿಕ್ಕುತ್ತೆ. 1 by 2 to the power of 3 ಅಂತ ಬರ್ದೆ. This is half 60 t half. I have written or simplified like this because if the base is same, I know I can equate the power. So 3 equals 60 divided by t half, or t half is equal to 20 minutes. So the answer is 20 minutes. Know some relations, practice that relations, apply to solve the questions.